Okay, I'm going to go ahead and start this lecture here. Today we're going over section 2.1. 2.1 covers polynomials. Now with a polynomial, it's going to be written in this form. A sub n xn plus a sub n minus 1 xn minus 1 all minus or plus all the way down to a sub 1 x to the 1 and plus a 0. Now if you think about it, this is just like, okay, some coefficient or some number x to the 4th plus the next coefficient x to the 3rd all the way down to where you have like 3x plus and then whatever your constant is. That's what that's standing for. Okay, so these right here, all of these in red are terms. They're called terms. And the number out in front of each term, these things here, this, those in purple are your coefficients. Okay? Your leading term. It's very simple to find. It's the term with the highest power of x, or the biggest exponent. Okay? The leading coefficient. Ooh, that one's hard. All it is the coefficient. If I could spell, be nice. Coefficient, there. What the shnikes? I want that. Of the leading term. And the degree is just the power or the exponent of the leading term. Okay? Now, here's where they try to get funny and cute and all that good stuff. And they tell you that the roots of a polynomial are when there is an equation, it's for an equation. Okay? And it's y equal x squared plus 2x plus 1. It's whenever y is equal to 0. And the zeros are for a function. In other words, instead of y, it's now f of x is equal to x squared plus 2x plus 1. It's the same darn thing. Roots and zeros are the same thing. Okay? Now, we're going to play with something that has a cubic. Okay? You can have many things. But let's do some examples. The first one, we're going to say that h of x is equal to 7 minus 4x cubed. First of all, they want to know what kind of function is that? Well, it's to the 3rd, so it's a cubic. The leading term is the term with the highest power. Well, there's only one with a power. It's negative 4x cubed. Okay? the leading coefficient. It's just what's in front of the x cubed is -4. And then the degree, the degree is just the power of the leading coefficient, so it's just 3. And that is your first example. Now your second one. P of x is equal to x cubed minus 9x. Is that a function? Yes, it is. Okay? Because this is the same as, if you write it all out, this would be the same as P of x is equal to x cubed plus 0x squared minus 9x plus 0. Now, it says to find the zeros of this function. To find the zeros of this function, just set it equal to 0. X cubed minus 9x equals 0. Well, factor out an x. Set them both equal to 0. Take square root of both sides of that. X squared minus 9 equals 0. X squared equals 9. X equals positive or negative 3. And I have x equals 0. So the zeros of this function are very simple. X equals 0, 3, and negative 3. There you go. All right. Let's look at evaluating these functions. So let's start with this one. P of x is equal to 4x cubed minus 5x squared plus 7x minus 9. They say find P of 2. Well, P of 2 would be 4 times 2 cubed minus 5 times 2 squared plus 7 times 2 minus 9. Well, that's pretty easy. That's 4 times 8 minus 5 times 4 plus 7 times 2 minus 9, which is 32 minus 20 plus 14 minus 9. If I put all those together, I should get 17. That is one way of doing it. I call that the long way. Now I'm going to show you the easy way. A lot of you saw this last year. It's called synthetic substitution. All I'm going to do is take the 2, and then I'm going to take all the coefficients. 4, negative 5, 7, negative 9. And then I'm just going to go. Bring the 4 down. 2 times 4 is 8. Negative 5 plus 8 is 3. 2 times 3 is 6. 6 plus 7 is 13. 2 times 13 is 26. 26 plus negative 9 is 17. I get the same answer. But it's much quicker in my mind. Okay, let's do another example. Let's say we're going to use that same exact equation, or function, sorry. P of x is equal to 4x cubed minus 5x squared plus 7x minus 9. Now this time they want us to find P of 3. That would be 4 times 3 cubed minus 5 times 3 squared plus 7 times 3 minus 9. Well, that'll give me 4 times 27 minus 5 times 9 plus 7 times 3 minus 9, which is 108 minus 45 plus 21 minus 9. If I put all those together, I get 75. Let's do it with substitution now. 3, I got 4, negative 5, 7, negative 9. There's 12, 7, 21, 28. Times 3 is 84, minus 9 is 75. Little quicker, little easier, and it's done. The last example I have for you. They're going to give you 4 is a 0 of f of x is equal to 3x cubed plus k times x minus 2. Well, if it's a 0, then you know that this is 0 and that x is equal to 4. You got to find what k is. That's the whole objective here, is finding k. Okay? Find k. Well, I plug that in. Now it's pretty simple, isn't it? 4 cubed is 64. So 0 is equal to 192 plus 4k minus 2. In other words, 0 is equal to 190 plus 4k. Move that over. Negative 190 is equal to 4k. Divide both sides by 4. K is equal to negative. Divide them both by 2. 95 over 2. There is my answer. Now that's your first lesson on polynomials. All right? Okay, that should do her. And we should be done with recordings for this week.